Okay, hello, what is up, everyone? Good evening. Okay, it feels like I haven't seen you in a while. Happy Chinese New Year, everyone. So anyway, welcome back. This is our February week 1. Okay, so today we will be continuing with our revision. So I hope you have received your latest notes, which is the chapter 4, 7, and 8 material. Okay, so this one, I think if you requested it in January, you should have received it by now. Okay, but if you haven't, okay, no choice lah. Just look at my screen, or you can just get this chapter 7 notes from last year. You can use it too. Okay, because it's almost the same thing. It's just that this is the compact, shorter version of it. Okay, so anyway, let's begin. Okay, this is our Form 5 chapter 7. Hang on. Yes, hello everyone. Okay, yes, hello Stephanie. Okay. Anyway, so chapter 5, Form 5, chapter 7, light and optics. I would say this is a very simple chapter. Okay, nothing to memorize. It's all about drawing. Okay, it's all about drawing. I'm sure you still remember these 5 diagrams we have learned last year, and maybe you have seen this thing in your trial this time. You know, your past trial, which is like what, 2-3 months ago. I'm sure you have seen this thing, and mostly this one they will ask in objective. Okay, you won't, very seldomly you will see this question in section B, which is your paper 2, because it carries too much marks already. Okay, they are not gonna, give you like one whole diagram and ask you to just draw everything. Okay, because it's too much free marks for you. Okay, anyway, so let's look at our beginning. Okay, lights and optics, cahaya dan optic. So formation of images by lens. So we start everything by kanta, which is our lens. And our lens has 2 types. If you still remember, the coming out one, it's called convex, which is kanta cembung. Okay, and you have the going in one, which is concave lens, kanta cekung. All right, so our focus will be this biconvex and the biconcave. These two are what? Plano, convex meniscus, not our concern. Plano, concave, convex meniscus, not our concern. Our only lens to focus is this thing. Okay, biconcave and biconvex. Okay, quick way to memorize this. Many people are still having difficulty. They get very confused. Concave is going in or out. Very easy. You look at concave, cave, what is cave? Cave is gua, right? Okay, you go into a cave. Cave is a gua, so you go in. So the lens goes in lah. Okay, when you have a lens going in, it's like a gua. So concave. That's how I memorize. Okay, so let's look at the convex lens first. Okay, convex lens, they will converge light ray. Okay, that means memfokuskan cahaya. That means concave convex lens, they will focus light to one point. Okay, to one point. They will concentrate that ray to a point. This is like your magnifying glass. I'm sure you know this, right? If you take a piece of paper, you put your magnifying glass here, they will focus your sunlight onto one point and the point will start burning. Right, so that's your converging light. Okay, converge means to focus, concentrate, converge. Okay, memfokuskan cahaya. Whereas your concave lens, your kanta cekung, they are to diverge your light. Okay, this is to mencapah cahaya. Capah means to go that way. Diverge. Okay, diverge, mencapah. That means I push the light ray out. Just now is to concentrate on one point. Now is to capah this thing out. Easy, huh? Okay, so optical terms, there are a few words about lens that you should know. This should be very simple and basic knowledge to you. Okay, so everything you start with the principal axis. This is called Paksi Prinsip, I think. Okay, if I'm not mistaken, this is your principal axis. Okay, that means you have a line here, and then your lens is here. Okay, at the middle of the lens, okay, the right in the middle, the tengah-tengah lens is your O, okay, which is called optical center. okay, which is called, what you call in BM, okay, tengah optic, center, pusat optic, sorry. Okay, sorry, brain fart. Okay, so this is your pusat optic, that means your optical center. That means this is the center of a lens. Every lens has a center. It's like a point of gravity lah. So every lens has a point in the middle. So whatever light that goes through O, they will pass through straight. No bending, no nothing. Can you see? When light passes through O, the light will not bend. They will just run straight through like this. Okay, so nothing really much to say about this O here. It's just the center point of a lens. Okay, so our focus will be these two. Okay, focal length and focal point. Okay, your titik focus and your jarak focus. Okay, so all lens is about where they focus. Okay, it's about where they focus. The point they focus, okay, that means all light will go to that point, like here, you see? That means all the light will go through this point. So this is our focal point. Titik focus, that means that point, all the light will pass through it. So like I said just now, if you have a piece of paper, you put your magnifying glass, it will focus light onto that point. That point is the focal point because all the light will focus at that one point. And then the thing will start burning lah. Okay, so that's your focal point. So titik focus lah. You don't need to memorize this thing. Okay, not important. And then what is your focal length? Jarak focus. That means the distance between the middle line and the focal point is your focal length. Jarak focus. Don't get confused. One is the titik, the point, and one is the jarak, the distance. Okay, so every lens has different focal point and focal length. This is what makes your glasses, I mean, if you wear glasses, I wear glasses, what makes your glasses and mine different? Okay, I'm sure if you wear glasses, it's most likely because you have short-sightedness, you have myopia, which is called rabun jauh. That means you cannot see far stuff, you can see near stuff lah. Okay, so if you wear glasses like me, why is your glasses and mine's different? Okay, I'm sure maybe your for example, okay, like my right eye is around 525 degrees, okay, and then my left eye is roughly around 475, if I'm not mistaken, or 425. Couldn't remember. Okay, so 400 something. That means my right lens, okay, this glass here, this piece of glass here, my right lens and my left lens, they have different focal point and they have different focal length. Why? Because my eyesight has different kecacatan lah. Apparently, my right eye is more cacat lah, so they need different lens for it. My left eye is not so cacat, so they need not so strong of a lens to correct my eyesight lor. So maybe yours is not like this. Maybe yours is 100 something, 70 something, or 200 something, 300 something. So it makes yours and mine different because your glasses have a different focal point and a different focal length. Mine is different from yours. Okay, maybe yours is even more serious. Maybe yours is 800 something, 700 something. Fine, whatever. Because your focal point and mine is different. So if you wear my glasses or I wear your glasses, I'm not going to see anything. You are not going to see anything because if you wear mine, your eyes will be out of focus. If I wear yours, I will be out of focus. Okay, so every lens has different focal length and focal point. So when you go for your eye exam, I'm sure every year or every 2-3 years, you go to those glasses shop, your optician, you will sit there, okay, the optician will ask you, okay, come look in front, red and green, which one you see better? Okay, they will point, come on, this alphabet, what is this? This one can you see? This one can you see? And then they will start changing your lens. Come, you see this better, right? Red color better or green color better? Then they will test both of your eyes lah. What are they testing for? They are testing for how cacat your eye is, what focal length and focal point they should use for your lens. So your glasses should be specially only for you. Okay, so this is your lens lah. So thickness of the convex lens affect the focal length. Okay, ketebalan kanta mempengaruhi jarak fokus. Okay, so I want you to write this down. The thickness lower, okay, the lower the thickness, semakin nipis kanta, semakin panjang jarak fokus. Okay, you can write these two arrows here. It makes your life easier. That means if your lens is thin, okay, thin as in going down, your focal length is going to be long. Okay, whereas if your lens is thick, your focal point is going to be, your focal length is going to be short. So they go in opposite. Okay, thin lens, long focal length. Thick lens, short focal length. So they go opposite like this. Okay, thin, long, thick, short. Okay, so they work like this. So this is why, like I said, if your eyesight reading is different from mine, we have different thickness. Okay, like my lens is freaking thick because my mine is 500 something, so my lens is like very thick. So if you wear very strong power glasses, you get what I mean. If yours is like 800 something, okay, basically you need to get thinner lens. Okay, you need to pay more to get thinner lens. If not, you just look like a nerd. Okay, ask me how I know, because mine is like that too. Okay, anyway, so let's look at our this one. I see thin, long focal length, thick, short focal length. Okay, really easy stuff. Okay, so this ray diagram would be our focus in this chapter, okay, which is this drawing thing. Okay, here's the thing. Last time during our time, okay, during my time as PM, they do ask this a lot in exam. Okay, they will ask you to draw this diagram, they give you 3 marks. Okay, they ask you to describe your image, another 3 marks. Wow, 6 marks like that leh. But do you think your SPM is gonna be like this? No, because it's too easy for you. Nowadays, your SPM is about this K-bar thing. They are trying to enforce the culture of not die memorizing stuff. They are trying to put this K-bar stuff to make you try to sort of think out of the box. Okay, so chances are, if you see questions like this in your trial, if you remember your 2-3, go and look back at your trial paper, chances are you will see questions like this in your objective, which is the ABC part. Okay, if they do ask this in section B, which is a paper 2, consider yourself lucky because it's so many marks here. Okay, but from what I can predict, SPM, they won't do it this way. Okay, so I'm just guessing here. Anyway, so there are 5 diagrams in your convex lens, as you can see. Okay, kanta cembung, you have 5, which is 1, 2, 3, 4, 5. Okay, why are there 5 diagrams here? Because there are 5 positions. Okay, if you look at your position, you have F and 2F. Okay, so why are there 5 positions? Because the first position, your object is at behind 2F. Okay, second position on 2F. Third position between F and 2F. Fourth position on F. Fifth position right in front of F. So you have 5 object here. So all you see, the first object, they are behind 2F. Second on 2F. Third between F and 2F. Fourth right on F. Fifth right in front of F. Okay, so all different position, they give you different image. This is why you have 5 diagrams. Okay, so this is why you have 5 diagrams. So should you memorize this all? Not really memorizing. Okay, this is really easy to draw. Okay, so before that, let us learn about this characteristic of image. I'm sure you still remember this. Okay, there are 6 words you use to describe your image. Okay, and they are magnified, diminished. Okay, I hope you still remember this. I did ask you to copy this down last year when we learned this. When was it again? Around August or September something. Okay, so magnify, diminish in BM is membesar dan mengecil. Okay, the second set of word is gonna be inverted and upright, which is BM is songsang dan menegak. And the third set of word is gonna be real and virtual, which is nyata dan maya. So I hope you still remember these 6 words. Let me explain this again if you forgot. Okay, very easy. Magnified means this. Okay, guys, these are to describe your image. Okay, what we are trying to describe is our image. What image do you see? So if your image becomes bigger than your object, it's gonna be magnified. Okay, magnifying glass, what membesar, okay, BM is easier lah, magnify, and then become smaller is diminished. Okay, mengecil, diminished. Please do not use other words. I have students who use become smaller lah, zoom out lah, all kinds of words that you can imagine. No, magnify and diminish, they are the only two accepted keywords. So please don't try to play it funny and give me some other words. No, okay, so magnify and diminish. And of course, the second set, inverted and upright. What is inverted? That means 从上咯. That means the picture comes out, the image comes out, the thing is reversed. Okay, so where do you see this? Okay, very easy. Later on, if you are free, you go and take your spoon. You know, a spoon, take your stainless steel. I'm sure you eat your dinner using the stainless steel spoon, right? Okay, your spoon has both sides. One is the concave side, the going inside, which is the part you use to take your soup. And then the behind, you have the convex side, which is the jembong side. Okay, I want you to look at your concave side, which is the jekong side. You look into that image, you will see yourself reverse inside. Okay, I don't have a spoon here to demonstrate for you. Okay, my kitchen is very far. Later, you're going to do this yourself. Okay, before you have your dinner later, you take your spoon, the concave side, you look at your mirror, you look at the mirror side, okay, the convex side, the concave side there. You will see yourself inside there, and your face is going to be reversed. That's songsang lah, okay, inverted. And tegak, menegak, or upright means they stand straight lor. That means it's like your phone camera, okay, your phone camera. Whatever picture you try to take, okay, let's say there's a tree in front of you, okay, the image here is like a tree stand straight, so that's upright lah, menegak lah. Okay, so what is real and what is virtual are these two words, many students, they still don't understand. Okay, very easy. When you have a screen, okay, you know what's a screen, in BM it's called screen. Okay, let's say you have a screen. Have you seen a projector before? If you have come to our, if you have come to physical class before, which is I don't know how long ago, okay, we use projector in DDC, right? So if you see an image on the wall is a screen. So if you see an image there, okay, that means this is real. Nyata, something real on the screen you see. So nyata. So if it is virtual, maya, that means you don't see an image on the screen. Okay, that means screen got no image. This one screen, it has an image. Other image pada screen adalah nyata. Kalau tiada image pada screen, ia dipanggil maya. Okay, maya, virtual. So what is virtual? It's like mirror. Okay, mirror. Okay, imagine this is a mirror. Okay, this is my iPad. Okay, so imagine this is a mirror. So I use this, I put this in front of you. Okay, I put this in front of you. You should be able to see your reflection here, isn't it? Okay, imagine you're standing in front of me right now. There's a mirror here. You will see yourself here. Okay, so if I rotate my mirror, can I reflect your image onto a screen? Do you see yourself on a screen by just going through a mirror? No, your image is inside here. Your image will not just go boom and boom, reflect to a screen. No, it doesn't. So a mirror's image is virtual. Maya, that means on the screen there's nothing. So this happens for your mirror. Okay, like I said just now. Okay, later you go and take your spoon. You look at your convex or concave side. You see yourself inside that. Okay, can you reflect that onto a screen? No, you can't. So that is virtual. Okay, Maya. So anyway, let's look at our ray diagram and characteristic of image. Okay, I know most likely. Okay, okay, then that's good. Okay, so to draw this ray diagram, I mean, if they ever ask an exam very easy. There's only two lines here. Okay, can you see the purple line? Okay, two line, purple line, and the pink line. So you need two lines to form an image. Okay, very easy. How do you draw the first line? First line always going through O. Okay, so I'm going to write this here. First line always goes through O, which is that optical center, the pusat optic. And as I said, anything that goes through O, the line is going to be straight. Straight, straight, straight. No bending, no whatsoever. So you see, the first line going through O, straight, no bending. Straight. Okay, straight, straight, straight. That's your first line. Okay. And then second line is to go through your F, which is your focal point. Titik, focus. Okay, so how do you do this? You draw it straight, okay, parallel to this axis here, okay, parallel, and then you bend towards F. Why is it bend towards F? Because remember, our convex lens is to focus our light onto one point. You bend in, okay, you bend in. So same thing lah, you bend in. Whereas later, your concave, it bends out. Here is in, focuskan cahaya. So you have two lines here. Okay, you have the purple line and you have the pink line. Okay, so wherever they meet, when these two lines they cross, that will be your image. Okay, your image will be formed there. Okay, so as you can see, go straight, bend towards F, 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 and go straight, bend towards F. They are the same. Okay, so this is why I said, hey, if they come up with this diagram, okay, you draw one line, two line, draw image, 3 marks, you know. Okay, 3 marks, you know. And to describe the image, is it real or virtual, diminished or magnified, inverted or upright? This one, another 3 marks, you know. So 6 marks leh. Okay, but like I said, our government is trying to discourage the culture of date memorizing. So they mostly won't ask this thing anymore. They will try to switch those kind of K-part thing lah. Like your sejarah question lah. You see every sejarah question they will ask for K-part stuff. Apakah iktibar yang anda perolehi? Okay, apakah ciri yang seharusnya pada seorang pemimpin? You're like, how is this sejarah? This is moral what? Okay. Apakah ciri pemimpin? Rational lo, bertanggungjawab lo, amanah lo. Isn't that nilai murni, sir? Isn't that moral? Yes. In fact, sejarah has become moral already because they don't want you to die memorize stuff. They don't want you to ingat fakta. No, they want you to think. Kononnya lah. This is what our government trying to do lah. So most likely they won't ask you bulat to draw like this. Not gonna happen. Okay, so but still you have to learn how to draw. Okay, so the first image, okay, the first diagram is going to be behind 2F. So first line, second line, okay, you will see an image here. Okay, so can you see your object is standing like this, your image is like this. So what do you see? If there's a screen here, yes, there is something on the screen, isn't it? So real lo, nyata lo. Like I said, if you see something on the screen, it's real, nyata. It looks real, nyata, true. And then this is inverted. See, songsang. And then this is diminished, okay, mengecil, becomes smaller. If you want to memorize this, I would recommend you to memorize where do you see this thing, okay, because this is more applicable in our K part. So you see this thing in a camera, okay, why camera? Because you see, okay, let's say this is my phone, okay, this is my phone, I take picture using my phone, okay, what do you see? Let's say you take a picture of a tree, okay, so this is your screen, okay, my stupid background is blocking, okay, this is my screen. So you will see an image on the screen, right? So there is something on the screen, so real lah. Okay, and then it's usually inverted. You must say, sir, I take a picture of the tree, it's not inverted here, what? Because your smartphone will reverse that thing back for you, okay? But on inside the camera here, okay, the image is usually inverted. Okay, it's just like your eyes, okay? I'm sure if you still remember your Form 3, when you draw your eyes, okay, when you draw your eyeball, let me find a space. Okay, when you draw your eyeball, okay, so let's say this is an image. When the image goes into your eye, your image looks like this. Okay, 从上 one, reverse one. So your eye is actually a camera. Same thing. So it's diminished, okay, mengecil, because the picture you take of the tree is like what, 3 meter, and inside your phone the tree is like 3 cm. Okay, diminished. So this is your camera lah. Okay, this is your camera lah. Okay, so that's the first application. Okay, second application, when your object is on 2F, okay, you do the same thing. First line going through O, second line straight going through F, and then you will see an image here. Okay, so in this case, okay, they are still real. Screen here, real, because there's an image on the screen. Inverted, songsang, because they go like this. And then this is neither diminished or magnified. It has the same size. Okay, size and sama, because you see they are same. They are on 2F somehow, you see, 2F, 2F. So they are same size. Okay, so where do you get this? Where do you produce something the same size? Your photocopy machine. Okay, your photostat machine. When you're trying to photostat something, you're trying to create the exact same size of the paper, isn't it? So that's your photostat machine. Okay, so if you look at your photostat machine, when the thing goes like that, okay, have you looked at a photostat machine before? There's a light ray that goes through to scan your thing, and then on that scanner thing, you will see a lens on it. That's this lens okay, to try to capture whatever image you're using. Okay, so third, between F and 2F, okay, same thing. Okay, first line going through O, second line going through F. You have a very big image this time. So on the screen, there is something real, okay, nyata, inverted again, songsang, and then magnified. Okay, this thing becomes bigger. So where do you see this? You see this in your projector. You go to cinema, this is what you see. Okay, because the film, okay, the film is like this small. But when you look at the screen is like what, 2 stories high. So that's your projector lah. Okay, when you come back to our physical class, if you still remember, well, when's the last time we had physical class? Okay, so when you see an image on the screen, it's usually very big. Okay, next one. So this case is a bit special. When you look at F, okay, they put at F. Okay, first line going through O, second line go straight, go towards F. Sir, these 2 lines, they didn't meet wall. They didn't meet wall. Yes, because these 2 lines, they are parallel. Okay, salari. So there's no meeting. So you will see something called image at infinity. Okay, image at infinity. That means the image is huge. Okay, very far away, very big. Okay, maybe they will meet somewhere very far away, like here, here. Then you see a very big image. Maybe. So is there anything on the screen? No. So it's virtual. Okay, and then this is upright. If there's an image, and then this is magnified, very magnified, like a few thousand times bigger. Okay, so what do you see this? You see this in the spotlight. Okay, on spotlight, they use this. Okay, even car, if your car has spotlight, okay, it looks something like this. Okay, next one, the last one. Okay, in front of F, what do you see? Okay, you do the same thing. First line going through O, second line going through F. Hey, there's no meeting here. How? You extend your lines to behind. There they cross here. So you will see an image here. All right, so if your screen is here, okay, screen is always the opposite side. If your screen is here, anything that's on the screen? No, so it's virtual. Maya, nothing is on the screen. It's like a mirror. Okay, it is upright. Okay, standing straight. It is magnified. Obviously, this becomes bigger. So where do you see this? This is in your magnifying glass. Okay, magnifying glass. So have you used a magnifying glass before? Okay, so if let's say this is what I want to see, this is a magnifying glass. I do this. My stupid background is blocking. Okay, you do this, right? You see something really close with your magnifying glass like this. Okay, so when you're putting your object very close to your magnifying glass, you are putting it in front of F. Okay, and then whatever object that whatever image that you see is going to be behind the lens. It's going to be very big in size. Okay, have you used a magnifying glass before? Okay, they don't project an image out on the screen, but in fact the image will be same size as your object. This is my object. Okay, when I look at this, my image is here. Okay, behind the object, inside the lens. There's nothing on the screen. So virtual. Okay, so very simple stuff. There's only 5 diagrams here. You might call it memorizing. I don't call it memorizing because it's nothing to memorize here. Okay, it's just drawing lines. Okay, it's just simple drawing lines. Okay, so if you look at our concave, okay, if you look at our concave, why is there only 2 images? In fact, concave has only 1 image. Why do I say so? Because remember just now we have 5. We put behind 2F, put on 2F, between F and 2F, on F, in front of F. Here, your concave, I don't care where you put, you will see the same image. you will see the same image. They have the same characteristic. This is why there's only one image here. Okay, you can go home and try this yourself. Wherever you put, you get the same image. Okay, different from just now. Okay, different from just now. This one, different position, you see different image. Okay, you see different image. Whereas this one, you get the same thing over and over again. Okay, so how do you draw this? Same thing. There are two lines here. First line is the purple line. Second line is the pink line. So first line goes through O, same thing. But second line, there's a little bit difference. Okay, just now, this is convex lens, right? Kanta cembung, right? Is to bend light down, bend light down, bend light down, bend light down, bend light down. Is to focus light onto one point. Concave is different. They are to mencapah the light. It's to spread the light away. So instead of bending down, you have to bend up. You have to go away. So first line, okay, second line going through here, and then you bend up using this F as a reference. Can you see the dotted line here? This is the reference line, and then you go up. So where do they meet? They meet here. Okay, the pink line and the purple line, they meet here. So you will see a very small image over here. Okay, so let's describe this. Anything on the screen here? No, so virtual. Okay, they are both standing straight, upright. Okay, tegak, menegak, and then they become smaller, diminish. Okay, so this is when your object is behind 2F. If you put it right in front of F, it's the same thing. You see, first line, second line, they meet here too. Same thing, virtual, upright, diminish. Can you see these two? They are the same. Okay, that's why in concave lens, there's only one diagram. No matter where you put, you get the same characteristics. So it makes it simpler. Okay, so you have 5 diagrams on convex, that's the complicated one, and you have 1 diagram on concave, which is the really easy one. Okay, so that's really all. Nothing really much to say here. Okay, let's do some exercise today, shall we? Okay, so next week I shall wrap up this chapter. Okay, I know it's a very boring chapter. Light is a very boring chapter. Okay, it is because it's just drawing lines. Okay, but there's nothing to talk about. All right, let's go to page 15. Okay, let's go to page 15. If you don't have the notes, don't worry. You just write your answer down for now. Okay, later you just copy back onto your notes. All right. If I'm not mistaken, when we learned this last year around August or September-ish, we actually did some of the questions. Okay, there are repeated questions. Okay, you can go back and look at that. So let's look at section A, number 1. Here's the thing. Section A is a must score for you. Okay, if you are still not familiar with the format of paper 2 SPM, your paper 2 has section A, section B, and section C. Okay, section C is the killer one. It has the essay there. Okay, remember the experiment question and 2 essay, you choose one. Okay, section A is going to be the simplest one because section A, which is this one, okay, section A, you don't even need to study. Section A, there's no studying factual stuff involved. In fact, section A is all about the experimenting. As long as you know how to write your variables, your MV, RV, and CV, you know how to write your hypothesis, you know how to write your inference, observation, okay, pemerhatian, what is your, what else? Operational definition, the hardest one, definisi secara operasi. What else? Objective, conclusion, okay, whatever lah. You can write all these experiment stuff, then you can score your section A already. Okay, no studying involved. Whereas section B, the one you need to study. That means you need to memorize stuff. Okay, so let's look at section A. Even if you don't know this chapter, okay, you look at the question, you know what they are trying to do. Diagram 1.1 and diagram 1.2 show an experiment to study the effect of thickness of convex lens on the focal length. So if you see this, so if I use a thin lens, okay, thin lens, oh, the focal length is long. Okay, and then if I use a thick lens, okay, if the thickness is high, so you will see very short focal length. You see, this is what I said in the notes just now. So thin lens, long focal length. Thick lens, short focal length. See, no studying here. So A, observe diagram 1.1 and 1.2. So A1, what can be observed between the focal length of the two convex lenses? What do you see here? What do you see here? There's no studying involved. So diagram 1.1 has longer focal length. Diagram 1.2 has shorter focal length. That's all lah. Okay, that's all. So you can say focal length, okay, of 1.1 is longer than 1.2. Okay, jarak fokus 1.1 lebih panjang daripada 1.2. What you see is what you get. Even if you don't study, come on lah, at least you can compare these two, right? Like I say, section A requires no studying. As long as you know what you are seeing, as long as you know how to explain. So, number 2, state one inference for your observation. I'm sure you know what inference is, right? Inference is why. Okay, mengapa? Why do you see what you see? That means you explain your observation. So your observation says this one has longer focal length. This one has shorter focal length. So now they are asking you why. Why? Thickness lah. Okay, this one has thinner lens. This one has thicker lens. So 1.2, the lens is thicker than 1.1 lor. Okay, so this is, like I say, no studying here one. Okay, so state one inference. So you can say lens of 1.2 is thicker than 1.1. Okay, kanta 1.2 lebih tebal daripada 1.1. Even if you have no idea about this chapter at all, you somehow forgot everything, hey, you can still do. Okay, because there's no studying involved here. All right, so B, let's look at B. What is the focal length of convex lens in diagram 1.1? Oh, goodness me. Okay, so you look at what's the focal length. So from here to here. If you don't know how to read ruler, go back to kindergarten, seriously. Okay, so this is 10 cm. Okay, this is 25 cm. So from 5 cm to 25 cm, that's 15 cm lah. Okay, like I said, no studying involved. You don't tell me you don't know how to read ruler. Okay, C, based on this experiment, here comes. State the operational definition for the focal length. Okay, many people, they are still confused. Sir, what is operational definition? What is definisi secara operasi? Yes, this is a bit hard, okay? But there's a formula for it. How do you write your operational definition? There's a formula for it, okay? Follow my formula. Okay, come. How do you write operational definition? Okay, what definition they're asking for? They want the operational definition for focal length. Okay, so what do? The first step, you just write back, focal length is first step. Okay, this is the first step. Whatever they are asking for, you put it back, you put is. Okay, it's like pendidikan moral lah. They ask you, apakah definisi kepercayaan kepada Tuhan? Moral is a stupid subject, isn't it? Okay, 18 nilai, you just hafal everything, go inside and write, then you get A already. Okay, so apakah definisi kepercayaan kepada Tuhan? So how do you answer? Kepercayaan kepada Tuhan ialah first step. Okay, whatever definisi they want, you put it back and you put is lah. Okay, so since they want the definition for focal length, I just write it back down. Focal length is, okay, this is the first step. Second step is something. So second step, something is what? What is it? Is it a factor? Okay, is it an object? Okay, is it a solution? What is it? What is it? So what is focal length? What is focal length? Focal length is a length. Well, obviously, panjang fokus adalah sejenis panjang. It's a length. Okay, I know this is a bit bullshit lah, but it is. So I don't know what else to say. Okay, focal length is the length. Okay, so panjang, not panjang, sorry, jarak fokus. Okay, jarak fokus adalah panjang. Okay, so third step, what do you write behind? Okay, very easy. Third step is you write your definition based on your observation, what you see, or based on your RV, your responding variable. Okay, so come, let's look at our experiment here. Okay, so what do you see here? What do you see about this focal length? What do you see about this focal length? So from both cases, we can see that the focal length depends on the thickness of the lens, right? Focal length depends on the the thickness of the lens. So you just write that lah. So focal length is the length that is determined by the thickness of lens. Okay, adalah panjang yang ditentukan oleh ketebalan kanta. So you write your observation based on what you see. Okay, this is not a very good example. Okay, let me give you one more. Okay, anyone of you still remember what is latex? You remember what is latex? Okay, the susu getah, the thing you cut from the tree, you know, when you go and tore the pokok getah, the white color thing, that's the latex lah. If you still remember, when you add acid to latex, okay, when you add acid to it, the acid will neutralize the charge, the latex will clump together, and the latex will coagulate. Okay, you remember this, right? Okay, akan menggumpal. Okay, latex akan menggumpal. So, if they ask you, what's the operational definition for acid? Apakah definisi secara operasi untuk acid? Easy lah. So, they want the definition of acid, right? So, just now they want something. You write the something law. So, acid is, first step. What do they want? They want acid, right? So you just write acid. Acid is, so what is it? Is it a factor? Is it a thing? Or is it a solution? What is it? So acid is a solution. Okay, acid is a solution. Asid adalah larutan. It is a solution. What solution is it? What solution is it? What do you see here? What's your observation? You can see that when you add acid, this latex coagulates, right? So you just write what you see. So acid is a solution that causes latex to coagulate. Okay, asid adalah larutan yang menyebabkan penggumpalan latex. You based on what you see, you write your definition. This is a very typical question. Okay, so don't be scared of questions like these anymore. Okay, many students they are scared by two things. Number one is inference. Like I said, inference is why. Explain what you see. Operational definition is you write definition based on what you see. Okay, in this case, they want focal length. You define what is focal length based on what you see. Okay, if you say, sir, I still cannot write this. What if in a certain case, I don't know how to write? Hey, it's 1 mark. Like I said, it's 1 mark. Your section A is gonna have 4 questions. It's gonna have 4 questions. Maybe in 1 or 2 questions, they ask for the operational definition. That's only 2 marks. Okay, you don't need to stress over the 2 marks. Sir, I really want the 2 marks there. Then the objective there, you get 2 more marks, right? Okay, this is harder to get. Objective, you just choose the correct one, you get 2 marks already. You get your 2 marks there. Okay, the best if you can get both lah. So you just follow my formula. Okay, 3 steps, you should be fine. Okay, so moving on. So this is only 1 mark. You don't need to sweat over this thing. So D, take on the optical instrument which use the same type of lens in diagram 1.1 and 1.2. So what uses convex lens? What uses convex lens? From what I can see here, okay, this guy is not a lens. This is a mirror. Okay, from what I see, this thing inside also has mirror. So these two, they are not lens. There's only one lens here, which is this guy. Okay, because light can go through this. Yeah, they focus light onto one point. Magnifying glass. Okay, easy peasy. Okay, so next, let's look at the next question. Okay, if you need to copy this, I'll give you a few minutes, a few seconds. Okay, moving on. Let's go to question 2. Diagram below shows an experiment to investigate the relationship between thickness of lens and focal length. Same question lah. You know what? Let's skip this. Okay, you see thin lens, longer length, thick lens, shorter length. Same question. Whatever. Okay, let's skip this. Okay, so let's look at section B. Like I said lah, section B, this one you need to study one. If you don't study, you cannot do, because they will ask for fakta here. They will ask something like our acid just now. Add acid will coagulate latex, or add alkali will coagulate latex. Fakta. Okay, what is penapayan? What do you add in penapayan? Your fermentation. Things you need to study. So number 3, label the ray diagram for the light rays which pass through the following convex lens and concave lens. Wow, 8 marks. Mimpi lah, they won't give you 8 marks. So what is the first? Number 1, what is this line? I think they're asking for this. This is your principal axis. Okay, Parkes principle. No, they won't ask for this. Okay, number 2, what is this? This is our focal point. Okay, titik focus. And then what is number 3? This thing here, the middle of the lens, the center of the lens. So that's your optical center. Okay, pusat optic. And the last one, what is this length here? Focal point is here. This should be your focal length. Okay, panjang focus. Okay, panjang focus. You think like that got 4 marks? No lah. Like I said, the government is trying to encourage K-BUT, okay, critical thinking. So they won't ask you to buta write things you memorize. Okay, so I'm just gonna go through this quick. So number 1 here, same thing. That's your principal axis. Number 2, this one is your optical center. Number 3, this is your focal point. And number 4, this is your focal length. Okay, I'm keeping everything short because this is not really coming out. So not our focus. Okay, moving on. Let's go to numbers. Let's go to C. Fill in the blanks with the correct answer. So a concave lens is known as a concave. It's this. Okay, so they will diverge light, right? They will capakan light, right? So it is a diverging lens. Okay, kanta mencapa. While a convex lens, convex, they do this, they focus light. So it's known as a converging lens. Okay, converging lens. Kanta memfocus, I think. So number 2, what is the distance between object and optical center? Okay, this is a stupid question. What's the distance of object? Object distance lah. Okay, I don't know what else to say. Okay, jarak object. Okay, what's the distance between object and the lens? Object distance lah. There's no special word for it. So what about image and optical center? Image distance law. Okay, jarak image. Okay, then again, things like this won't come out in exam because it's simply too easy. They won't give you 4 marks like this. They will give you 1 or 2 marks by explaining a long sentence. So you don't really see 4 marks in section B. It's most likely going to be 1, 2, 1, 2, 1, 2. Anyway, moving on. So this is like an understanding question. So number 4, they're asking for all the diagrams. Wow. Okay, if you have the notes, okay, you can draw it together with me lah. So the first one, they have done it for you. Okay, first line, the purple line, and the second line goes straight and bend down. So this is your image. Okay, let's describe our image. The description will be more important. So when you have here, and there's a screen here, right? So this is real. Nyata. This is reverse. So this is inverted. Songsang. And what else? Oh, this is bigger. This becomes smaller. So this is diminished. Okay, mengecil. There, 3 points, 3 marks. So next, object is on 2F. So you do the same thing. You draw the first line to O. I'll try to draw as straight as I can. We did this in what, August last year, I think. If I still remember this. Okay, I think we have done this in the old notes. Okay, so your object is here. All right, so same thing, there's a screen here. So something is on a screen, so real. Nyata. Inverted as well. Songsang. And this neither becomes bigger or smaller. If you can kind of see, it's almost the same size. I know it's not very clear, but they should be the same size. Okay, size sama. Okay, my diagram is not the best in the world, but I hope that you can kind of see they are the same size. So next, between F and 2F, you do the same thing. So first line going through O. Okay, second line goes straight and to F. Oops, not long enough. Okay, they're kind of here. Ooh, this is really big. Okay, so same thing, real. Something is on the screen, nyata. Inverted as well. Songsang. And this becomes magnified. Membesar. I know this is redundant lah. You will most likely see this in objective. But still. Anyway, next one. U on F. So the first line goes through optical center. Second line straight and to F. And in this case, they will not meet. Even if you extend this thing, they will not meet. So in this case, image is at infinity. Okay, they are like here, very big. Okay, but still you need to describe the image. Anything on the screen? No. So this is virtual. Maya. This is upright. Tegak. And this is very magnified. Besar. Okay, here mah. So magnified lor. All right, last but not least, okay, in front of you. So first line goes through your O. Okay, second line goes through F. Okay, the 2 lines didn't meet, so you can just extend your straight line here. Okay, so your image is here. Okay, so screen is here. Anything on the screen? No. Virtual again. And then this is upright again. Tegak. And this becomes magnified. Like your magnifying glass. Okay, so let me zoom out. If you need to take a screenshot, or you can, if you don't want to take a screenshot, you want to draw it yourself, yeah, sure, go home and draw it yourself. Okay, this wouldn't take you very long, 5 minutes at tops. Okay, we have drawn this once in last year. Okay, now we're doing it again. Okay, hopefully I don't need to repeat this chapter again. It's a very boring chapter. It's a very repetitive chapter. Okay, there's no calculation, there's no memorization, there's nothing to understand here. It's just the 3 words over 6 words, okay, over and over again. A ray diagram over and over again. Okay, you know what? I think I'm gonna stop here. I would say that's it for this chapter. Not this chapter, okay. Next week we shall wrap this chapter up. Okay, so anyway, have a happy Wednesday. Okay, so far what chapter we focus on? I'll make a list of chapter that you should focus on. Okay, why not you list? Okay, here's the thing, guys. You list down the chapters you are weak in. Okay, and if you want, you can ask me what chapter you should focus. Okay, I would rather you focus on chapters you are weak in. You don't tell me everything. Sir, every chapter also very weak. Then good luck to you, lor. Okay, try to list out those chapters that are weak in. I will kind of tell you what you should focus more. Okay, so happy Wednesday, everyone. I shall see you next week. Okay, hope you have a great week. Happy Wednesday. So see you again. Bye-bye. Good night.